Hello and welcome to Calculus in the AM, already in progress. In case you're just joining us, this is Calculus in the AM. I'm your host, Mr. Sundaka. We're looking at asymptotes and intercepts. We reviewed quickly. From algebra, you know vertical asymptotes are the values where your denominator gives you 0. Horizontal asymptotes, we're going to look at this. The limits of infinity, going to the left and to the right real quickly. We were just going to look only at the horizontal asymptote for this question here. So that means we're looking at the limits of infinity. If you remember your rules for the limits of infinity, fine. In this case, the denominator has a higher degree than the numerator. So if you remember that, it equals 0. But if you don't, this is the strategy. What's the expression you get when you multiply through this then? X approaches infinity. We get 2 over x on the numerator plus 5 over x squared. You'll quickly see that you get minus 1 over x minus 20 over x squared. Yeah. You see that you get? Then what? If you put in a really large number? 0 over 1, right? Which is still 0. So that means the x-axis is the asymptote in that particular case, right? Okay. Now I asked you guys, and we don't recall from our limits chapter, what happens when the degrees are the same. So we're going to just try it out, and you'll probably remember it now for the next while. If you ever take this again, I'll do it. Scared me. Okay.
Can you just take it out?
In a sense. So we're going to do it this. I'm talking, I can't do this. I'm going to look for the horizontal asymptote. Horizontal asymptote on 0 there. Now, I'm not stating it formally, I'm just doing the rough work here. X approaching infinity. Now, 6x cubed plus 1. 2x cubed minus 4x squared. Multiply top and bottom by the highest degree from the denominator always. 1 over x cubed. And in a sense, I think I know what you're getting at, Ava. We get 6 plus 1 over x cubed. I forgot the limit notation though. So. I'm going to make my x cubed look like an x cubed. Over 2 subtracting 4 over x. Quick glance.
Ratio of lead terms.
You remember now.
Yes.
Usually what you do one the long way, you'll say, hey, when the denominator and numerator have the same degree, highest degree, you just take the ratio of these lead terms. 6 over 2 is 3. You're going to have 6 plus 0, 2 minus 0, 3 is your horizontal asymptote. Now, neither one of these, I didn't write them as formal statements. What's the horizontal asymptote in A? We say 0, but what is it? Is it x equals 0 or y equals 0? Y equals 0. And then here, horizontal asymptote. I can go with HA, don't worry. Ha. If y equals 3. Okay? What's that? You see there?
Yeah.
6 divided by 2, which is 3. The others? Oh,
Remember this?
okay. No, that's fine. Okay, so then this is the limit of x approaching, just think a large number. Infinity is the idea. So 1 over a billion is 0. 4 over a billion. Okay, you get the idea there? You're not just saying yes.
No, I'm because yeah.
Okay. Okay, I forgot to continue recording, but it's just algebra, it's not actually calculus. Y-intercepts are the values where x value is 0. We found that by plugging in x into our expression. X-intercepts are where the y value is 0, and you usually have to do some factoring. Now, can you factor that in your head, the denominator, by the way? Like, where do we have vertical asymptotes in this? X minus what? X minus plus what?
I'm just wondering, couldn't you just multiply the denominator?
Yes, and I was just saying, this is an aside.
Yeah.
-4. X minus 4.
Yeah.
So positive 4 is a vertical asymptote. Not that we are asked for this, but the vertical asymptotes are x equals 4, right? And then 3, or 1, I mean, sorry, blah, 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 to add up to -3. So -1. Okay, I'm just throwing that as an aside. Now, Miss Jackson just mentioned, do we even worry about the denominator? No, because you could think of, is this what you were mentioning, I think? Yeah. The denominator is rubbish, right? Because if I multiply both sides by this denominator, it zeroes up. So we're really only factoring this, and it's a sum of cubes.
Oh, yeah.
By chance, anybody remember the
Oh,
formula?
I just remember
That there is a formula.
there's a formula.
Okay. And that's why I was saying, on a test, I wouldn't do this to you cold. You can flip back in your book and look this up. So, x plus 2. You guys remember how this works?
Yeah.
Yeah, what's the rest?
X plus, x squared plus 4 minus 4. I don't know.
No, you don't. Okay.
Close. Who's the bigger?
Close. No. It's actually x squared minus 2x plus 4. And you'll never, if this is done correctly, and this had no common factors in this, you won't be able to factor the quadratic part. Okay? So just think this through. Yeah, does this work? X cubed. Yep. Minus 2x squared. Yep. 4x. Okay, get my x cubed. Then minus 4x. I get 2x squared too. So they cancel out, and then I get my 8. It does work. So, the long and the short of it is, what is my x-intercept? And there's only one x-intercept. Because you can't solve one of these.
Negative.
-2. Leslie. So,
That's all I did too.
so as an ordered pair, that's -2, 0, right? As an ordered pair, this one is 0, -2. It's just coincidence that they're both -2 involved, right? Okay. There's some asymptotes on that and stuff. Now, I'm not going to worry too much about these because it is algebra skills. You're rusty on them. If you know if you need practice, but I have to pause this here.